Fog, called Gora or Dhund in Hindi, has been an enigma and mystery for masses. No wonder loss of proper visibility sparked many suspense stories in Indian cinema, which are now milestones. But the fact remains, fog is a hard-hitting weather hazard which India experiences every winter. The Indo-Gangetic Basin (IGB), encompassing northern India, experiences fog during December-January due to favorable meteorological conditions. There are several different types of fog, each forming under different conditions. Depending on the origin and formation, 6 different types of fogs are identified across the world. But the fog on Indian landmass is typically radiative fog and advective fog. Radiation fog forms in situ at night under clear, cold and relatively calm conditions, when water vapor close to the cold ground condenses as it cools. This fog is localized event and mostly formed in the morning, lasting for few hours. Advection fog forms when moist warm air flows over a relatively cold surface and is cooled. When this happens, the air can no longer hold moisture and so condenses, forming fog. Normally during November to mid-December and in the month of February, radiation fog occur in North India. During peak winter of mid-December to end January, North India gets covered with mix of advective fog and radiation fog. Two premier scientific institutions of country, New Delhi-based India Meteorological Department (IMD) and Pune-based Indian Institute of Tropical Meteorology (IITM) joined hands together to improve fog prediction scale. The IGI airport is the worst hit airport in India, so it was chosen as the primary site for the experiment. A collaborative mission called Winter Fog Experiment (WIFEX) was implemented during 2015-2018 consecutively for 3 winters to observe various patterns and parameters of fog formation. It is important that we know about fog, its characteristics, what causes it, and how do we kind of predict it. So with that in mind, Ministry of Earth Sciences has started the experiment called as WIFEX to understand the fog. This is being done currently at 2 places, one in Delhi's IGI airport and one at Hisar, and their data is collected about fog and the ambient conditions which causes the fog. Successful and effective implementation of WIFEX in 2015-2018 consecutively for 3 winters jointly by IITM and IMD with world-class observational facilities helped to improve fog prediction. Winter Fog Experiment (WIFEX) helps in understanding different physical and chemical features of fog. Onslaught of dense fog hits aviation sector badly due to low visibility on runways. Under such conditions, Air Traffic Control (ATC) finds itself unable to take an informed decision on whether or not a takeoff or landing is safe. As a result, flights are delayed, cancelled or diverted, causing a heavy toll on financial health of aviation sector. Runway visibility measuring instruments were available in overseas markets to help, but their cost and maintenance expenses were too high to afford. Rising to the occasion, the CSIR, National Aerospace Laboratories (NAL) at Bengaluru have designed and developed indigenous visibility measuring system Drishti. CSIR, NAL and India Meteorological Department (IMD) signed a partnership agreement in May 2014 to install Drishti at all major international airports in the country. Technically, Drishti is a transmissiometer, which determines runway visual range by measuring certain parameters of light transmission in atmosphere. Drishti works on the principle of transmission of light or the attenuation of the intensity of the light. Depending on the atmospheric condition like fog, rain or a smog, the intensity of light reaching from the Drishti transmitter to the Drishti receiver reduces, which is equal to a distance, and that distance is what the pilot will be seeing on the runway as his landing and takeoff. RVR with their live visibility have improved user outreach and better runway-based fog reporting to air traffic control and airlines.